Hi everyone, my name is K. Prakash from CSM department. Today my topic is about traveling sales problem using bounce and bound. Introduction to traveling salesman problem. The traveling salesman problem is a classic optimization problem is combination optimization. It aims to find the shortest possible route that visits a set of cities and returns to the original city. The problem is NP hard, meaning non-known polynomial time solution exists for large dataset. You can see the diagram of the introduction of traveling sales problem at the right side of the slide. Introduction to bounce and bound. Bounce and bound is an advanced technical used to tackle optimization problem like TSP. It combines the concepts of viewing and bounding to reduce the search space. This technique is particularly useful for large instance of TSC, where traditional methods fail. You can see the bounce and bound diagram at the right side of the slide. Problem differentiation. Given a set of cities, each with distance to every other city, the goal is to minimize the total travel distance. The salesman must visit each city exactly once before returning to the starting point. The problem can be represented using a wide graph where verticals represent cities and adjacencies represent distance. The traveling salesman problem. You can see the diagram. Starting from city 1, the salesman to travel to all cities once before returning home. The distance between each city is given and it's assumed to be the same in the both directions. Only the length shown ought to be used. Objective minimized the total distance to be traveled. Key concepts of bounce and bound. All polynomial energy, you can see the Y. Polynomial kinetic energy. All political energy, the ball does not bounce as high as started. Vertical plus kinetic energy, all kinetic energy. Setting up the problem. You can see the diagram here. Initial bounding. Consider the minimum cost flow problem shown below, where the B1 values flow generated or given by the node the C1 values cost per unit flow or given by the arguments and the U1 or values or coupled or given between C and D. Formulate this problem B. Use genuine to solve this model. Exploring solutions. The algorithm explore possible route to be restriction visiting unknown cities. Each time a city is visited, the current cost updated and checked against the bound. If the current cost exceeded the bound, that path is discontinued from the consideration. Handling bouncing. Bouncing occurs when the algorithm explores a node that has potential but hasn't been fully elevated. By temporarily bouncing back to previous nodes, the algorithm on find alternative routes. This flexibility allows the algorithm to adapt to various configurations of this route. Purring efficiency path. You can see the proper purring principles. Hardware and different between configurations. Implementing the algorithm. The bounce and bound algorithm can be implemented using research of lateral methods. Data structures such as procedurally queries and graphs and efficiency for efficient travels. The implementation requires careful management of the state space to avoid redundancy. Equation factoring algorithm intervals factorations y analytical. Calculate the fractionals of number using a loop. Pn is the number localized effectively. Return n is returned You can see recursion factorial algorithm. Algorithm differentiates fractions by an integral. Calculates the fractional of a number using recursions. Pre n is the number to be raised factorially. Time complexity. You can see the diagram clearly here. Next, comparison with other techniques. Bounds and bound is often compared to branch and bound, which is a more general approach. While both methods aim to reduce the search space, bounds and bound is more specialized for TSP. Each method has its advantages, but bound and bound can yield better result in TSP scenarios. Finally, the conclusion is that CSP remains a critical area of study in computer science and operations research. Techni- Technicians like bounds and bound provide valuable instance and methodologies for solving complex problems. Continued exploration and revision will lead to even more efficiently solutions in the future. Thank you.